Now our next program is to find out odd and even numbers, or we can say counting the even and odd numbers in an array of 10 numbers. Before moving to check whether the number is even or odd, we should have an idea how to check that number is whether that number is even or odd. Now, first we know that at the if in decimal number system, if at the unit place we have 1 or if we divide the number by 2 and if remainder is other than 0, then that number is called as odd number, and if the remainder is 0, then that number is called as even number. So in a binary number system, if at LSB position, least significant bit position, if we have 0, then that number is called as even number. Means that number is divisible by 2. If we have 1 at LSB position, then that number is called as odd number. How to check that we will see now. So this is for to find out odd or even numbers. Suppose I have data A2 and I want to check that whether that number is even or odd. Now what I will do, first I will write in binary format A2. 1010 will represent A and 0012 will represent as 0010 will represent 2. So A2 is represented in 8-bit format. Okay. Now what I will do, I will do the logical ANDing of this A2 01H so that I can check the LSB position bit of this number. If I multiply this with this, means bitwise logical and bitwise multiplication. If I do logical AND operation, then what is going to happen here? Here, this 01H, which is nothing but same 01H in binary format, will be multiplied. Bitwise multiplication will be done, and the result will be generated like this. So if I multiply 1 with this 0, will generate 0. 1 into 0, 0. 0 into 0, 0. Likewise, if I multiply 0 into 1, 0. Now I got the result 0, 0H. If the result 0, the 0 flag will be set. If the 0 flag is set, then we have to understood that the number A2 is an even number. Is an number. So we know that at LSB position of A2 is 0, which indicates that the number A2 is an even number, and we have to count that number. Okay, for finding odd and even number or counting and odd and even numbers, we have two separate programs. Program is to count the odd numbers in an array of 10 numbers of 8 bits each size, and second is to find out to count even numbers in an array of 10 numbers each of size 1 byte, or we can say 8 bit. So this is how we will find out whether that number is even or odd. Means we will do logical ANDing with 0 1H. Whenever we are doing logical ANDing in 0 1H, why I have taken at 0 1H? Because I want to check LSB bit position. Suppose here in place of 0, if 1 is there, then it will come over here. The result will be, if in place of say this 0, if it is 1 here, then 1 into 1 will be 1. The result will be 0 1H, which is nothing but other than 0, means remainder is other than 0, and that number will be treated as odd number. That number will be treated as odd number. So this is logic behind this, and we will see the program now. As usual, we go to the TASM software. This is a ninth experiment. So XPT, sorry, edit XPT 9a.asm. So this is the program to count odd numbers from array or list of 10 numbers. So here I have written algorithm that we will AND, means we will do logical ANDs the given number with 0, 1h, that I have shown just now. If the result is 0, then we have to understand that remainder is 0 and that number is an even number, is an even number. And suppose if the remainder is not 0, then that number is an odd number. As usual, I have written dot model small. In dot data, we have 10 dot data assembler directive will initialize the data segment. List is the variable which is of size byte, which is defined with the, or we can say declared with the assembler directive define byte, and which has 10 values. These 10 numbers we have stored here up to this. And this is the array of numbers, or you can say 10 numbers. Now we have to check that we have to go with each number. We have to check each number whether it is odd or even, and if it is odd number, then we have to count it. Okay, as usual, code segment declaration we have done here with the help of dot code move x comma add data move ds comma ax. Now we know that initial count is we have to store the count in one register. We know that for we will use ch register for counting odd numbers. Initially we don't know the count, so we will initialize it with 00h. Now latest count is 0, that is we don't have any odd number. And now what we have done, we have taken offset address of list variable into the SI, means SI will get the offset or effective address of list. So a compiler will come over here. Okay, compiler will come over here. At that place we have value 10h. Okay, now we will use CL register. We know that CL register is used for counting purpose. Now here we have 10 numbers and that we have to check. So we have to go checking one by one. So we have to maintain that count in CL register. 10 numbers is nothing but in hexadecimal it is represented as 0AH. Okay, so that we will move to the CL register. So this is it is with the help of move CL comma 0AH. Now what I have done, I have multiplied, I have taken first value. So I have taken move AL comma SI register value at the address effective address of SI register. Value at the effective address of SI register is 10h now. That will be moved into the AL register. That will be moved into the AL register. Now that value I will make a logical AND with 0, 1h, so that I will check whether that number is even or odd. This is the instruction and AL comma 0, 1h. So in this instruction, content of AL, that is 10h and 0h. Logical means bitwise multiplication will be done and the result will be generated. We know that if the result is 0, then the number is even. If the number is no, if the result is not non-zero, then the number is odd. So here we will check that content of AL. If the zero flag is set, suppose zero flag is set, zero flag is set means result 0. If result is 0, then that number is a even number and we do not count, we do not want to count that number. Okay, it will come to the next here. It will come to the next here. Okay, now if the result is 0, if the result is 0, then this condition will be unsatisfied. It will be unsatisfied and it will execute this instruction inch. Why inch? Because we got the odd number and we are storing count of odd number in ch register. So what I will do, I have to increase that count from 0 to 1. That's why I written instruction increment ch. The content of ch will be incremented by 1. Okay, so ch becomes 1 if the number is odd. Now if we look at this number, here the unit at unit bit position we have 0. When the 10h it is ANDed with logical and application operation is done with 01h, it will generate the result 0. It will generate the result 0. So it will set the 0 flag. Now here we have checked the condition. Jump if 0 flag is set. Go to next. We want to skip this step. This step is for if the 0 flag is not set. If the 0 flag is now for 10h data, 0 flag is set, we will increment. We want to skip that number. We do not want to count that number as the number is even number. Now we want to check next number. So our compiler should go to next position. Next position can be achieved with the help of SI register content. Offset address of SI register should be incremented by 1. That's why I have taken this instruction. Increment SI. Now I have checked one number. So count should be decremented by 1. That numbers count I have stored in CL register. So it will be decremented by 1. So the number of remaining numbers are 9. Now I have to check whether all numbers are checked or not. If the content of CL after decrementing is 0, then I have to stop the checking whether that number is odd or even. If it is not 0, means some numbers are remaining. After execution of this instruction, CL content becomes 09h, and that 09h will not will reset the flag, 0 flag. So this condition will be satisfied. JNZ again. So then jump if not Z. Jump if 0 flag is not set. Now after the decrement CL, the result is 09h, which is non-zero result. So this condition is satisfied. 0 flag will be reset and it will go to again. And again next number I will check into AL register. Next we have cursor at this position and the content are 21h. Now 21h will be logically AND with 01h. 21h, when it is logically AND with 01h, it will generate non-zero result. Non-zero result indicates that we got odd number. We got odd number and we have to count it. After getting non-zero result, 0 flag will be resetted. And if the 0 flag is reset, then this condition is unsatisfied. This condition is unsatisfied and it will execute next instruction inch, means we got first odd number and that count we are maintaining in ch register. We got first odd number. So ch register content will be incremented by 1. Previously it was 0, now it will be 1. It means that we have counted first odd number. Okay, then we have to go for next. So we have to repeat this step. We have to go to the next memory location by incrementing the SI register content. So it will go to the 71h. And we have checked two numbers. So we have to decrement the count of counting the numbers. So it should be decrement, which is in, that count is, we are maintaining CL register. So we will decrement that count by 1. And if it is not 0, then we have to repeat the process. Means if it is 0, it indicates that we have counted odd numbers and we have to stop now. But here Still, after decrementing the CL, the count will be 08H, and we have to do the process again. So if the count is 08H, which is a non-zero result, zero flag will be resetted. Then this condition will be satisfied. Then again it will go to here. So again, at this position, we have value 71H, which will be taken into consideration, and it will be moved to the A register. And it will be logically ANDed with 01H, which will create non-zero result. So non-zero result indicates that we got odd numbers. We got odd numbers. If the number is odd, then we have to increase the count which we have stored in CH register. So here the condition will be satisfied. 71 is the odd number, and it will not execute this instruction. It will move to the next instruction, that is INCCH. It will increment the count by 2. Previous count was 1. So next time after execution of INCCH it becomes 2. So we got 2 odd numbers. Again we have to go for checking next number, which is 46. To go to that location of value 46, we have to increment the SI counter by 1. So it will go to the next memory location. As we have checked 3 numbers, we have to decrement the count, and we have to check whether we have finished all checking of all numbers or not. If not, then go again and repeat the process. So this whole process will be repeated, and odd numbers will be counted here in CH register. After counting all odd numbers, we will move that count in BL register, storing the answer. Okay. And with the help of these 3 instructions, we will terminate the program. Move H, 4CH, INT 21H. So if you look at here, in these 10 numbers, wherever we have 1 at LSB position, or we can say odd number at LSB position, that will be the odd number. So out of 10, we have 1, 21H, 71H, F1H, 11H, 57H, and 19H. These are the odd numbers. Means 1, 2, 3, 4, 5, and 6. So we should get count 6 odd numbers. There are 6 odd numbers out of 10 numbers present in an array or list of numbers. So we will save this program. Exit. TASM file name is axpt9a.asa. There is no error. There is no warning. TLIB file name is axpt9a.obj. TD axpt9a.exe. So we came to our processor window. With the help of F8, we will say observe here, observe the values and count in the CS register. These first 2 higher byte of CX register, that is CH, will denote the number of odd numbers. How many odd numbers are there? CX register will count the how many numbers we have checked and how many are remaining. So with the help of F8, we will do the execution. See here, first number we got in AL register as 10H, and in CL register we have 0AH. 0A is nothing but 10 count we are having, and we are going to check first number. Now we have ANDed first number, we got the result 0. in AL register. As we got the register in AL0, we got the result 0. The 0 flag is set here. 0 flag is set here. In the as 0 flag is set, we have we should understood that it is a even number and we do not want to count it. Next, F8. Now count is decremented by 1. Means one number we have checked. Remaining are 9 numbers are there. Next number is taken into consideration 21H. Result generated is 01H after ending with 01H. Whenever 21H is ended bitwise with 01H, result is 01H. So result is non-zero. So if the result is non-zero, 0 flag is reset. 0 flag is reset to 0. Now we got first odd number. So CH register content should be 1. Here CH register contents become 1. We got first odd number. Now we have checked two numbers. So our count should be decremented by 1. It means that first this count is decremented by 1 in CL register. So count is 08H. This way we have to do execution. Go on F8. See here we got 06 as a count in CH register, which are the odd numbers. Now here CL contents become 0. As CL contents become 0, we have checked all numbers and we got the result as 06H, which is the number of odd numbers present in array of 10 numbers. So we got the result in CH register. And in last step, we have written that that count should be moved to the BL register 06H. BX lower byte of BX register. So we have moved that count into the lower byte of BX register, that is BL. So BL got the value 06H. So this is how we will count odd numbers out of 10 numbers present in an array or list of numbers. Now our next program is same second part of this number. This experiment is we have to count odd numbers. 9b.asa. So this is the program to count even numbers from array or list of 10 numbers. Same thing I have done here, same procedure I have used, but just here if we are counting the odd numbers, In previous program we are counting even numbers. So out of this same numbers I have taken dot model small dot data. In that we have declared variable list, initialization of code segment. CH register will note down the number of even numbers, or we can say it will note down the count of even numbers. The offset of list variable will be moved to the SI register, so that SI program counter compiler will come over here. And in CL register we have count of numbers, means how many numbers we are checking. So here currently we are checking 10 numbers. Then one by one it will be decremented. Now content of content at present at the offset address of SI, which is present here, will be moved to the AL register. Now it will be moved to the AL register and it will the 10H will be value 10H will be moved to the AL register and it will be ANDed with 01H. When 10H is ANDed with 01H, it will generate result 0. Then 0 flag will be set. If the 0 flag is set, we have to understood that we got even numbers. We have seen in already. If the result is 0, then number is even. When 10H is logically or bitwise ANDed with 01H, it will generate the result 0 result which will set the 0 flag. If the 0 flag is set, then we have to understood that that number is even and that number has to be counted. Now here I have written J and Z. Jump if not 0 to next. This is written because if we found that non-zero and that non-zero result indicates that the number is odd number, and we do not want to count that number. That's why I have written this instruction. But currently, the result generated is 0, and it will set the 0 flag. If the 0 flag is set, then I have to understood that I have got even number, and I want to count that even number. So we are counting the even numbers in CH register. CH register. So that number, that count should be incremented by 1. Previously, CH register count is 0, means we do not have at this position, we do not have any even numbers, but we got first even number, so I have incremented the count by 1. So CH register content becomes 1. So first even number I got. Now I want to check this next number, that is 21H. To go to the next number, I have to go to this memory location. I will go to that memory location by moving the incrementing the offset address which is present in SI register. For I have written instruction increment SI. Increment SI. So it will go to the next memory location where we have value 21H. Where we have value 21H. That we will take into the again AL register. Now we have moved to the next memory location. We have checked one number. So whatever count of number having in CL register, that should be decremented by 1. It indicates that we have checked one number and remaining how many numbers are there. So if I decrement the CL register content, which is previously was 0AH, nothing but 10, which will be decremented by 1. So it becomes 09H. So 9 numbers are remaining to check whether that numbers are even or odd. Okay. So the count is not, the 9 numbers are remaining. Still we haven't finished the operation. So we have to repeat the process. If the count is 0, which indicates that we have reached up to the last, but here we have not reached to the last number. The count is not 0. Then we have to repeat the process. So J and Z. To again it will come over here. Content of SI register offset content will be moved to the AL. Currently we have 21H data that will be logically ANDed with 01H, which will create non-zero result. If it is not zero result, the 0 flag will be reset to 0. It indicates that the number is odd number and we do not want to count that number. If we do not want to count that number, we have to skip this process. We have to skip this instruction. So this condition is satisfied previously. Result is non-zero. Non-zero result will satisfy the condition jump if not 0, and it will go to the next. Means this count will increasing the count of even numbers will be escaped. The compiler from here will directly jump to the next, and it will come to the next memory location here, and it will increment the content of SI to go to the next, to go for next number, which is 71H, which is 71H. Now in 71H we have checked two numbers, so count should be decremented by 1. So I have written instruction decrement CS. After decrement the CL, I will get the result 08H. 08H. So it will indicate that we have it indicates that still 8 numbers has to be checked. So if it is non-zero, I have to go for checking the next number. So if I decrement CL content by 1 and it is a non-zero result, then zero flag is reset to 0. So here I have written the condition jump if not 0, means if the 0 flag is reset, go to again. It will go to this instruction. Okay. Again, next number will be taken into AL, which is 71H. It will be ANDed with 01H, logical AND operation, bitwise multiplication. That will be done, and result generated will be a non-zero result. Again, if the non-zero result we got, then it will not set the flag, zero flag, means it will reset the zero flag. The resetting the zero flag indicates that we got odd number and we do not want to count that odd number. So it will go to directly next. It will skip this instruction as here the condition is satisfied. Okay, it will skip here and it will increment the content of xi. Means it will go to the next memory location, which is 46H. Now we have checked three numbers. We should decrement the count from 8 to 7. For that purpose, I have written instruction decrement CL. Now it is not 0, means still we 7 numbers are to be checked. So I will use the instruction jump if not 0. If not 0 means if the 0 flag is reset. When the 0 flag is reset, when we decrement the count of CL register from 8 to 1, 8 to 7. So it is non-zero, it will go to again. Again, I will take that number, next number into the AL register, which is next number is 46H. Okay, 46H will be taken into AL and it will be logically ANDed, or we can say bitwise multiplication will be done between 46H and 01H, which will create the zero results, which will create the zero result. When a result created, a real result generated is zero, it will set the zero flag. Means we got the even number and we have to count it. So what is going to happen here? This JNZ next instruction will be unsatisfied. Okay, and it will increment the count of CH register, which is previously was 1, now it becomes 2, as we got two numbers. We got two even numbers. So out of these four, if you observe carefully, we have got two odd numbers, two even numbers, 10H and 46H. So this is how the process will be repeated until 19H. Now we have taken same data as that of previous program. In previous program, we have seen that there are 6 odd numbers. There are 6 odd numbers. So remaining numbers, how many remaining numbers are there? Only 4 remaining numbers are there. That numbers are the even numbers. That numbers are 10H, 46H, 26H and 64H. These are the 4 even numbers. So this is how we will count the even numbers and we will get the result in CH register, and I will move that count into the BL register for storing purpose only. And next, with the help of these 3 instructions, we will terminate the program. The result in BL will be 04H, which is nothing but 4 numbers are even numbers. 4 numbers are even numbers. We will save this. Exit TASM file name ext9b.asm. There is no error, there is no warning. T-link file name is ext9b.obj. td file name ext9b.exe. So we came to our view. Now see here, observe the AX register. In AX we have two parts, AH and AL. In AL register we will always take the data, and in CX register CH will count the number of even numbers, and in CL register we will count the remaining numbers. How many numbers has to be checked? So we will do it with the help of F8 function F8. So first number 10H is taken into AL register, and now count is showing 0A. 0 is nothing but 0A is nothing but 10H. 10. Count is 10, and it is available in lower byte of CX register, that is CL. Now we will check F8. The result that is 0. Whenever 10H is ANDed with 01H, result generated is 0H. In AL we have 00H. If the 00 result is there, result got 0 and 0 flag will be set. So here the 0 flag is set here. Okay, if the flag is set, we have to understood that the number is even number, and we have to count that number. So we have to count that number, means that count we have maintained in CH register, higher byte of CX register here. So it will be, it should go to 0 1. See here, CH register got 0 1. Now we have checked one number, and we have to decrement the count of numbers by 1. So that count we have maintained in CL register. Currently it is showing 0H. After DEC CL instruction, this instruction, this 0A count will be decremented by 1. It becomes 09H. See here, it becomes 09H. Now we'll next take next number in AL register. We have taken 21H, and which is the odd number, so we should not count it. So here the result generated is 01H. So non-zero result we got, it indicates that we got odd numbers and we do not want to count it. And also here the 0 flag is reset to 0. This 0 flag is resetted. Resetted means its value becomes 0. So we do not want to count that number. So we just decrement the count of CL register by 1, as we have checked two numbers. So count becomes 08H. As 08H indicates, still we have to check 8 numbers. So it will go on doing. Third number taken 74H, 71H, which is an odd number. Again non-zero result will reset the 0 flag. 71 means 3 numbers have checked. So CL contents is 07, as 3 numbers have checked and 7 number has to be checked. Now next number is taken into AL register, that is 46H. Now 46H is a even number, so that will be counted in CX register. So CX register content becomes, after ANDing 46H with 01H, the result generated is 00H. It will set the 0 flag. That count has to be zero flag is set. It indicates that the number is even number, and we have to increase the count of even number in which is maintained in CH register by 1. So this 01 should be incremented by 1, so it should be 2. See here, CH register becomes 02, and we have checked 4 numbers, so 6 numbers are remaining, which is indicated in CL register. So we have to repeat this process until we reach last element or last number. So if you observe here, we reached to the last element, counter is 0, and we got 4 in CH register we got number 4. It indicates that there are 4 even numbers present in array of 10 numbers. and that will take into the BL register, lower byte of BX register, 04H. So this is how we will count the even numbers from array of 10 numbers. Now our next program, which is not in the experiment list, but it is available in the syllabus, to count positive or negative numbers. To count positive or negative numbers. This program is not in the list of experiments for practicals, but it is in the syllabus. Okay. Now basic of that, counting the positive and negative numbers. First we will see, and then we'll write the program. So this is the basic behind the to find out positive and negative numbers. So first of all, suppose assume that we have 8-bit data. In that 8-bit data, MSB position bit will indicate the sign of the number or sign of the data. This red shaded bit is the MSB bit, most significant bit. Okay, and this 1 is nothing but LSB bit, least significant bit. Now at MSB position, MSB bit indicates the whether that number is odd or positive or negative. And this bit is called as sign bit. Means in 8-bit sign number, we have one sign bit which will represent the sign of the number, and we have 7 magnitude bits, or we can say value bits. So 1 plus 7, total 8 bits will be there. Now if you observe carefully here we have number minus 17, which is represented in decimal format. D stands for decimal. This is minus 70. Okay. Now how to represent this in sign binary format? For minus we have 1. So it will be represented by this one, MSB position 1. What indicates that the number is even number? The number is negative number. And the rest of the bit will represent the magnitude. Its magnitude is 17. 17 value is there. So how to represent 17 in binary format? So to represent 17 in binary format, 7-bit binary format, we have values 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1. So this is the 17. Okay. And if we consider in hexadecimal, if we convert this number in hexadecimal, we have to make group of 4 binary bits. So these 4 binary bits will represent, means this 1001 represent 9 and 0001 represent 1. So minus 17 is represented as 91H in hexadecimal format, signed hexadecimal format. And we have to count these positive or negative numbers. Okay, so what we have to do? We have to check the sign bit of each number. We have to check sign bit of the each number. Suppose it is 1 and logically ANDed, when we do logical AND with ATH. Why ATH? Because we want to just check only this bit. If it is, say, if the result generated is 1 into 1 is 1, it indicates that sign bit has value. This one indicates that the result is negative number. The result is negative number. This one is indicates that the sign of the number is sign bit of the number is negative, means that number is a negative number, and we have to count that two numbers whenever we require. Okay, if suppose this bit is 0, if this bit is sign bit is 0, then whenever we do logical and, that is bitwise multiplication, it will generate the result. Say 0 into 1 is 0 only, so it will generate the result 0. It indicates number is positive number, and we have to count according to in which program we are doing the work. And so if we are counting the positive numbers, then we have to increment the count by 1. If not, we are working in negative, we are counting the negative numbers, then this step has to be skipped. Okay, so this is how we will check whether that number is positive or negative number, by adding 80h with the number. Now we will see the program. I have stored that program with the name PS. So edit ps.asm. So this is the program which I have written to count the positive numbers from array or list of 10 numbers. Logic is simple here. Here I have written algorithm that we are ANDing the given number with 80h. If the result generated is 0, then it indicates the number is positive. If a result generated is non-zero, as we have seen already, then the number is negative number. The number should be stored in the correct format, that is sign format, in which we have MSB bit will represent the sign of the number, whether that number is negative or positive. For negative number, sign bit will be 1, and for positive number, sign bit will be 0. And rest of the 7 bit will be will represent the magnitude of that number. Okay, as we have seen that 17 minus 70 in a decimal number system is represented as 91h in hexadecimal number system. So that range will start, negative number range will start from, it will start from 80h, and it will be, why 80h? Because it will be possible that only sign bit will be 1 and remaining all bits will be 0. That is 80h. And maximum range will be, sign bit will be 1 and all remaining bits will be 1. So it will be minus 127h. That minus 127h is represented as FFH. Okay, so it will be minus FFH. Okay, so so here the 80 is the non-negative number. 80 is the non-negative number. So here we have, as usual, I have written dot model small dot data initialization of data segment, and then that we have a variable list. In that we have 10 numbers, and we have to count positive numbers. We have to count positive numbers. I have initialized the code segment with the help of these 3 instructions. Now I will maintain that count as that of we have seen previously. I will maintain that count in CH register. I will move the offset address of list variable into SI register so that I can access each element, each number. Now currently, after execution of this instruction, move SI comma offset of list, the offset address of list variable will be taken into SI register, and the SI register will be at this position. Okay. In the lower byte of CX register, that is CL register, I will maintain the count of numbers. we have 10 numbers. So I have to maintain how many numbers I have checked for counting the positive numbers. So that count I will store in CL register. So move CL comma 0AH. 0A is nothing but 10. Now first what I will do, I will take that number into AL register, first number, and then it will be logically ANDed with ATH. Now for that purpose I have written instruction move AL comma SI, content of offset address of SI register. Currently the SI register effective address showing this memory location which has value 10H. Now that 10H will be taken into AL register. 10H will be taken into AL register. If 10H is taken into AL register, we have 10H data, and we will do that logical ANDing with ATH. When 10H is logically ANDed with, or we can say bitwise multiplication is then done with ATH, it will represent the value, it will generate the result. So which is a it will generate the zero result. The zero result indicates that the number is positive. And if the number is positive, we have to increment the count of positive number which is which is maintained in CH register by 1. If the when the 10H is logically ANDed with ATH, bitwise multiplication is done and result generated will be 0H, 00H. 00H will set the flag to 1. Zero flag will be set. Zero flag set indicates that the number is positive and we have to count that positive numbers in CH register. So we have to escape this instruction is for condition for this instruction is unsatisfied. JNZ next means what is going to happen here? Result generated will be 0, zero flag will be set. We got first positive number and we have to increment it. Now, if suppose if the number is a negative number, that time we have to skip that part. We have to skip that number for counting of that number as the number is negative number. For that purpose, I have written instruction J and Z next. If the negative number is non-zero, if the non-zero result is generated and we have to understood that that number is negative number, that time we have to skip this incrementation of CH register. But now currently when we do the logical ANDing of ATH and 10H, the result generated will be 00H. It will set the zero flag. As the zero flag is set, we have done that we got first positive number and we have to count it. The count will be incremented by 1 as we got first positive number. Previous count was 00H which is maintaining CH register. So this condition will be unsatisfied as zero flag is set. If this condition will be unsatisfied and this it will execute next instruction INC CH. So if CH content which is previously 00H will be incremented by 1 to 01H. So we got first odd number, first positive number and it is maintained in CH register. Now we got first positive number. Now next we have to check this 20H. We have to check this 20H. We have to check 20H. Now for that purpose we have to go to the this memory location of 20H. Currently the my compiler or pointer is at this location 10H. So it should be incremented by 1. So for that purpose I have written instruction increment S. So it will go to the next memory location where we have value 20. Okay. Now after going to the second memory location where we have value 20, we have to decrement the count of checking the numbers that we have maintained in CL register. So for that purpose I have written instruction decrement CL. Now previously CL content was 0AH. 0H. So it will be decremented by, it becomes 909H. So 0A is nothing but 10. When it is decremented by 1, it becomes 9. So still 9 number has to be checked. Now to, as still we have to check 9 numbers, we have to go and repeat the process. For that purpose, I have written instruction jump if not 0. If the CL contents are not 0, then go to the loop again. Go to the loop again. Now here it will take the value present at the offset address of SI. Currently the SI at the memory second memory location, and where we have value 20H. 20H will be taken into AL register and it will be ANDed with 80H. When 20H is logically ANDed with 80H, it will generate result 00H, which will set the zero flag. If the zero flag is set, we have to understood that we got another positive number and we have to increment the count. So it will be incremented, the count will be incremented by 1. This JNZ next instruction will be skipped as condition is not satisfied. JNZ jump if not 0, but if we got the result 0, that's why this condition for this instruction is not satisfied. So it will execute next instruction, that is it will increment the count of CH register by 1. In CH register we are maintaining the count of positive numbers. So for previously it was 1, now it becomes 2, and it will we have to go to check for next memory location content, whether it is positive or negative. That is, we have to check 70H. Now this process will be repeated until 89H. Until 89H, the process will be repeated. And as soon as we reach to 89H, when we decrement the CL register content by 1, the content of CL registers becomes 0. As soon as it becomes 0, the 0 flag is set. This then Z jump if not 0, that condition is unsatisfied and it will execute next instruction move BL comma CH. So this BL register is it is used for storing the count of positive numbers which is available in CH register. And with the help of these following 3 instructions, we have terminated the program. Move AH comma 4CH INT 21H end. So now if you observe here in these 10 numbers, whichever number is above 80 or above, that will be treated as negative numbers. That will be treated as negative numbers, because we know that in signed magnitude format, if we place sign bit as a 1 MSB position and remaining 7 bits are 0, so it will start from 80H. From 80H to it becomes FFH. Okay, so which here we have this one F1H, 84H and 89. These are the 3 negative numbers and remaining are the positive numbers. So we should get the result 7 numbers which is in BL. Now we will see it. Save, exit, TASM, ps.asm. There is no warning, there is no error. T-link, ps.obj, next ad, ps file name .exe. Here observe carefully here AX register and CX register. In CX register, CH will maintain the count of positive numbers and CL register will maintain the count of numbers to be checked. Now it will be done with the help of F8, single stepping, goes on pressing F8. So first number came into AL register as 10H and we count 0A in CL register. Now first number we are checking Whenever it is logically ANDed with 80H, the result generated is 00H, which will the result is 0, which will set the zero flag. Which will set the zero flag. If the zero flag is set, we have to understood that we got the positive number. So count of this CH register, higher byte of CX register should be incremented by 1. Now observe carefully here also. So this cursor has came here. Increment the CH register, execution is done. Now count is incremented by 1. So in CH register we got first positive numbers. And now as we have checked one number, we have to decrement the content of CL register. Okay. Content of CL register is decremented by 1, so it becomes 9. So still 9 numbers we have to check. Then we have to go again on checking. Next number. So second number 20 is taken into AL register and it will be logically ANDed with 80H. Result generated is 0. As the result generated is 0, 0 flag is set. 0 flag is set indicates that we got another positive number, and so that number should be that count should be maintained in CH register. CH register content should be incremented by 1 as it becomes 2. So it becomes 2. Now we have checked two numbers. So count should be decremented by 1. That is, it goes to from 9 to 8. So it becomes 8. So this is how the numbers are checked, and final count will be available in CH register. Now here the count is finished. In CL register 00H is there, means we have reached up to the last element and we got 7 positive numbers. The count is available in CH register, higher byte of CX register 07, and that we will move to the BL register. See here 07 is available in BL register, lower byte of BX register. Function so this is how we have to count the positive numbers. Same way we can do here counting of negative numbers. Edit negative. That is so program. I will search first. So counting of negative numbers already written, I think so. No problem. We will convert that this program into counting of negative numbers. First of all, we will save as some another name. We will do say ng. Now we will make the changes. First of all, we are counting the negative numbers. Theory is same here. All steps are same. Just here instead of JZ use JNZ, use JZ only. So if the zero flag is set, indicates that we got positive number, and here we do not want to count positive numbers, we want to count negative numbers. So positive numbers should be counting of positive number, that step should be escaped or skipped. This is the only one make change. Rest of the things will be same. So here in this array we have this F1H, 84H and 89H. These are the three negative numbers. So we should get the result in BL register as a 3. Three numbers are negative. Save it. Exit. TASM file name is ng.asa. T-link ng.obj td ng.exe. So we can up to processor window. I will do it with the help of F8 button. Observe the AX and CX register. In CX at CL register we got the count for counting the checking of numbers. Still we have to check 10 numbers. That's why count is 0H. First number we have taken in AL register, that is 0H. It is logically ANDed with 80H. So result generated is 00H, which will set the zero flag. The setting the zero flag indicates that we got positive numbers and we do not want to count that positive numbers. We will skip this number and we will not in count of CH register currently, which is 00H. Now see, we have checked the one number count, remaining 9 numbers are there, which is represented as 09H in CL register, and still the count of CH is 0, which indicates that still we haven't got negative numbers. In CH register we are storing the count of negative numbers. So goes on doing F8. If you observe carefully here, CL count is 00H. It indicates that we have checked all numbers. We got 3 negative numbers. We got 3 negative numbers. So this is how we have to count the negative numbers, and we will maintain that count in BL register. Currently the BL register is 00H here. See the BX register. So it should be filled with 03 value, which is the count of our negative numbers. See here count is 03H. We got 3 negative numbers. So this is how we have to do counting of negative numbers program. Thank you.